Hello world, welcome to my 13th tutorial solving problems with programming. This tutorial is about the WSQ12 estimate E, and what are we going to do at first is see this picture 2.718 that stands for the number of E. After see this picture we are going to read the task. What to do in this assignment, you will estimate the mathematical constant E, that stands for the numerical Euler number. You should create a function called calculate E, line E, which receives one parameter called precision that should specify the number of decimal points of accuracy. You will want to use the infinite series to calculate the value, stopping when the accuracy is reached. Previous and current calculation are the same as the specified accuracy. So what we're going to do is read about the infinite series. As you can see, in infinite series, first we need to look or the number E that I said before. This the number is a mathematical constant that is the base of natural logarithm. The unique number whose natural logarithm is equal to 1. It is approximately equal to 2.71828 and can be calculated as the sum of the infinite series. If you don't know what is infinite series, click here, series. And you go in mathematics, a series, informally speaking, is the sum of the terms of infinite sequence. You have this sequence of the sum from n equals to 1 to infinity of 1 over 2 power to the n. It will be 1 half, 1 fourth, plus 1 eighth, and will be all the sum of the infinite sequence. So there you go, and we can estimate the number E as an infinite series of n from 0 to infinite of 1 over n factorial. That will be 1 over 1 plus 1 over 1 plus 1 over the 1 times 2 plus 1 times 1 times 2 times 3. Until 1 to 10 to the n factorial. And what it happens is you estimate the number. Also, there's other way of calculating the number E. There's a lot of ways, but no one of them ever give an exact answer because E is irrational. Okay, so for example, if I put the number n to 1, it will be the function 2. It will not be 2.7 or 827 or 8. And this is now because the n increases. The function approaches to E as n gets bigger and bigger. And this n will be, in this task, the precision that will ask for the user to approximate E. So you need to remember that, for example, if it's 1, it will be 2. If it's like 5, it will be approaching more to the real value. So I have already done the code. I have it right here. I'm going to explain each step as possible. First, we need to do include the library stream library to call all the functions of inputs and outputs of data in language C++, mastery topic 1. And for this topic of the accuracy and the specific decimal points of the numerical E, in my case, I use this library, IOManip, library to call all the functions of inputs and outputs to manipulate data in language C++. I'm going to explain with the other functions of IOManip. And this is also master topic 1. Then I have using namespace std. In C++, we need a command that every time goes with the instructions of inputs and outputs of data that is called std, but with this command helps writing this std out of the main because the machine factorizes them. So we have now the beginning of the program in main. In order to make the order, I have declared float variable precision. That will be the variable that will be asked to the user to give. So I have again master topic 4 command of data in form of text, specify the number of decimal points of accuracy. I have to say to the user, give me the number of decimal points of the accuracy, like said this in the example. And I have now the master topic 5. That is in precision. This command allows enter the data for inputs. In this case, is enter value of variable precision because I want to pass that number as a parameter when I call the function calculate it. So I have a command data in form of text. The estimation of E equals to precision. The precision, well, in this state, we show the authentic output of the value entered or position in the terminal interface, master topic 4, but also the value of calculate E with the parameter precision. So after doing this operation, the main goes to this function calculate it with the parameter precision that will be the number of precision that entered the user. Okay, so jumps to the other function that is a Flaw Function. This is a structure or a function where you have subroutines in order to make different tasks. In this case, we have a Flaw Function with the name calculates it and with float parameter precision. I put it the name precision. Again, precision. In order to have float results inside this function. So what are we going to remember is this task is similar to the factorial that we saw before because we know how to do the factorial. So you just we need to do this sum and aggregate to this value of E in order to make the value E. So you can see my tutorial about the factorial number. I have it in YouTube. You can see it. So, okay, I'm going to do the formula of the factorial. Okay, so it will be this one. As you see, you can start from 1. You can start from 1 from the series. So, I have to declare a float variable E initializing 1. That's why, because the series starts from 1. Then I have 4. With this, command 4 is utilized as a loop for execute all the instruction that has this loop until does not complete that the variable I will be less or equal than the numerical value of precision variable, while it is increasing 1 in 1 in this variable I initialized from the value 1. So I need a loop in order to make the repetition of these values until n. That will be the precision that wants the user to give. So that's why this sum I need the for loop. So in this for loop I do the sequence. It will E that E equals to 1. It will be 1 plus 1 over the number of factorial. This is a math operation between E and the value of the float function factorial with the int parameter I, and it stands for do the sum of E and the inverse operation of the factorial function with the I parameter and save it in the float variable E. This is the operation of the infinite series. Thanks to the recursion, master topic 16, use of the recursion for recursive algorithms. So it will be the loop. So in this operation, I call another function, the value of other function with the parameter of the value E that will be from 1 to until the precision that gave the user. So I'm going to call the factorial function that we saw in the last chapters of the course. I have a function where you have subroutines in order to make different tasks. In this case, we have a Flaw function with the name factorial. Within parameters n in order to have in results inside this function. So I'm going. So what it's going to do is that part will be the factorial that I said before, 1 over the factorial. So it will be the factorial. And so I need to do like a subroutine or another function to give me the value of n factorial. And how do you do n factorial? Okay, you have your parameter int n, then you do the recursion thing. In this case, we have an if master topic 10 uses the if statement. This command allows the condition if the value of n is equal to 0, and when this condition will be true, the task inside of the statement will execute. In this case, if the value of n is equal than 0, this will occur. In this case, 0 factorial is 1. So return the function 1. Okay, and for the other cases, we need a recursion. We need to increase the number times the previous value of the number. So that's why we have an else. Mastery topic 11 uses else with a conditional if. If the condition does not achieve, on the other hand, you will do this. And you return this value that will be the recursion thing. Return the recursion value n factorial equals to n times to the n minus 1 factorial to the function calculate e, like we did in the last WSQ6. Okay, so this gives you the value of factorial. So the factorial gives you in this part, this is over 1 over the number of factorial, and it's going to repeat it as long as the recursion executes until it reaches the precision. It will be the number of the precision of here with the parameter I from this to the precision. So it will be recording, and it will change the value of the previous E. Okay. So after doing this loop, I have to use the functions of the library IOManip. Have a flat notation for manipulator, and as you can see, we have a cout, but this cout with this instruction doesn't appear in the screen, but has a specific purpose with the library I put. This is a flat notation for manipulator of significant figures or decimal points after the decimal point. Hence, for example, a precision of 5 that gave the user, then the value will be precision 5, and we fix after the decimal point is shown for the number of decimal places that the user wants. In consequence, the value of variable e we suffer after this operation. I do this because with this I get certain values, but that I need to count the decimal places that I want the user to give. So that's why I put fix precision, the number of the precision that gave the user. This is entered for the user at the beginning. So it will be all the operations after this operation will change to set precision of this. That will be the significant figures. But with this command fix, it's going to count these positions from the decimal point. So it will be like how many decimal points after the number you want to see from E. If you see, if the user put 2, it will be the first two decimals of n factorial. That will be these ones, just 7 and 1. Or if you put just 1, it will be just 1. And what we saw before, if you just put 1, it will be the result 2. So that's why it's a consequence of the operation. So it will suffer the number E, and then we have to return the number E. With this command, you return the value of the previous operation of calculate function inside of the variable float e in order to call it in the main function. So this in this function returns the e and goes to the main, and then the main then appears as a command of data in form of value and in text with the value now calculate precision that will be this one. So after this long tag, I'm going to save this and I want to show you that I'm right. So for example, if the user gives you 1, it will be the precision of 1 has to give me 2. So I'm going to compile it. Remember G++ WSQ12.cpp and remember point/a.out. There you go. Specify the number of decimal points, so accuracy will be, I say 1, right? So 1. There you go. The summation of e with 1 decimal points is e equals to 2.0. And if you can see, just is 2. It's just one point. So what happens if I increase, for example, 3? There you go, we have 3. That's why I put the fixed thing. With this fixed thing, I get the decimal prompts from counting from the decimal point. I put 6, so it will be 1, 2, 3. And I'm closing to the value of e. If I put, for example, 5, I'm approaching, but I'm not okay. So, well, I'm approaching the value of v. So what happens if I put the number of 10? There you go. I have 10 value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why I put fix and the set precision. The set precision just tell me that I need to make all the numbers decimal, but including this one, and with the fix tells me to count this from the decimal point. So there you go. And I want to show you that I'm right. For example, the e constant, it will be 2.71828, and I have the example of, there you go, 2.71828. There you go. So I think I'm correct. I'm going to show you this to my teacher. I think it's okay. I'm going to upload it, and this is a contribution of the WSQ. So thanks for watching.